What's up, everybody? In this video, we are going to explore creating an animation that will select a random pixel, turn it on, and then turn it off using the Arduino Uno R4 LED matrix. The goal of this lesson is to better understand how frames are created and updated using the LED matrix. Open the Arduino IDE and create a new sketch using our template we created in Tinkercad. Fill out the information in the header of our code. Update the program name and description. The program name is LED Matrix Random Animation, and the description is a sketch where we will turn on and off a random pixel on the Arduino LED matrix. Load the libraries and declare the variables. Include the LED matrix library by typing #include space open quotation mark Arduino _LED matrix.h quotation mark. Next, an instance of the LED matrix. Type Arduino LED matrix space matrix semicolon. Now, let's define our frame. This is an 8x12 array representing each LED on the matrix. I've added this code in the description of the video to make it easier for you. This is a blank frame where all LEDs are off. In the setup function, we need to initialize the LED matrix. Add the line matrix.begin, open and close parentheses, semicolon. Now, let's create our animation in the loop function. We'll start by randomly selecting a pixel and turning it on. We will do that by randomly selecting a row and column and changing the value from 0 to 1. Each time we iterate through the loop function, it will change the frame array, meaning that any value I change from 0 to 1 has been saved in the frame array. In the loop function, type int row equals random, open parentheses, 8, close parentheses, semicolon, and int column equals random, open parentheses, 12, close parentheses, semicolon. When you call the random function, you pass the minimum and maximum parameters, unless your minimum is 0. Then you just send the maximum. Next, we will create serial.print, open parentheses, row, close parentheses, semicolon, and serial.print, open parentheses, quotation mark, colon, quotation mark, close parentheses, semicolon, and serial.println, open parentheses, col, close parentheses, semicolon. This will allow us to see which row and column are randomly selected. Next, we're going to change the value of the random row and column from 0 to 1. Below the serial statements, write frame, open square bracket, row, close square bracket, open square bracket, call, close square bracket, equals 1, semicolon. What this is doing is taking the X and Y coordinates of the pixel and turning on the LED by changing the value. Next, we need to render the frame. Type matrix.renderBitmap, open parentheses, frame, 8, 12, close parentheses, semicolon. Last, change the delay to 100. Upload your code to the Arduino. When the program executes through the loop, you will see that a random LED is selected. If you wait long enough, all of the LEDs will turn on. You can press the reset button on the Arduino and it'll start again. We are going through the process of updating a single LED so you can get a better idea of how to work with individual frames in an animation. Each time we call the renderBitmap function, we are sending information about every single LED to the Arduino matrix, telling it which should be on or off. Each time we iterate through the loop, we are selecting a random row and column and changing the value from 0 to 1. Over time, the frame array goes from all zeros to all ones. Okay, let's try something else. Now, we will turn off the LED before completing the loop. To do that, we are going to set the value of the XY coordinate to 0. After the delay, type frame, open square brace, row, close square brace, open square brace, call, close square brace equals 0, semicolon. And matrix.renderBitmap, open parentheses, frame, 8, 12, close parentheses, semicolon. Upload your code to the Arduino. When the program executes through the loop, you will see that a random LED is selected, turns on for 100 milliseconds, and then turns off. Because there isn't a delay between the previous pixel turning off and the next one turning on, it is instantaneous as it goes from one LED to the next. Let's do one last thing. Let's change the duration in between LEDs changing. After we declare our random row and column variable, add int duration equals random open parentheses 50, 2001 close parentheses semicolon. This will pick a number between 50 and 2000, so 50 milliseconds to 2 seconds. Add the serial statements serial.print open parentheses quotation mark colon quotation mark close parentheses semicolon and serial.println open parentheses duration close parentheses semicolon, and change the serial.println open parentheses close parentheses semicolon to serial.print open parentheses close parentheses semicolon. Upload your code to the Arduino. When the program executes through the loop, you will see that a random LED is selected, turns on for a random duration between 50 milliseconds and 2 seconds, and then turns off. Awesome! We just created a random, endless animation on an 8x12 matrix. You can adjust how many random numbers you call and play around to create your own patterns. At the end of this video, you should understand how to create an endless animation turning on and off individual pixels on the Arduino LED matrix.